Hi, we are VO Lab from National Tsinghua University. Today we'll be presenting our work titled Segment Anything Even Occluded. This is a joint project with our collaborators from NVIDIA, National Taiwan University, and Aeolus Robotics. Let me first introduce the task we focus on. A model instance segmentation. Given an input image, the goal is twofold. First, the model needs to identify and localize all recognizable object instances. This is the typical detection step. Then, for each instance, it needs to predict a segmentation mask that covers the entire object, including any parts that are partially hidden or occluded. This means the model needs to go beyond just seeing. It must reason or hallucinate the occluded shape based on context and prior knowledge. So what are we aiming to do in this work? We noticed that state-of-the-art detectors like Dino or VITZ already perform extremely well at localizing objects. So instead of building a full end-to-end model that does both detection and segmentation, we asked, why not leverage these strong detectors and focus solely on the model segmentation part? Our objective then is to create a dedicated segmentation module that can take in detected boxes, either model or model, and predict the complete object shape. Think of it like a plugin, a lightweight modular component that can be used on top of any existing detector, ideally without requiring joint training or fine-tuning. Our solution is called Samuel, which stands for Segment Anything Even Occluded. During inference, Samuel takes as input an image in a bounding box, which can come from either a model detectors or regular model detectors, and outputs the model mask of the object. We base Samuel on the efficient SAM architecture, and we fine-tune the mask decoder using a large-scale model segmentation dataset that we collected and annotated, which we will talk about later in this presentation. By training it with both a model and model boxes, Samuel gains flexibility, allowing it to work with a wide range of front-end detectors.
Building upon the framework just introduced, one of our key contributions is a model LVIS, a large-scale synthetic dataset containing over 300,000 images designed specifically for a model segmentation. To generate this dataset, we first use Samuel to predict pseudo-model masks from the LVIS and LVVIS datasets. We identify complete objects by comparing Samuel's pseudo-model predictions with ground truth visible masks. Occlusions are then generated by cropping and pasting randomly selected occluder and occludee pairs. Each synthesized image is paired with its original unoccluded counterpart, forming dual annotations that help prevent occlusion bias during training. To support model training, we curate a comprehensive model dataset collection composed of over 1 million images and 2 million instance annotations. We apply dataset-specific filtering procedures to ensure high-quality and diverse occlusion scenarios. This large-scale cleaned collection allows Samuel to learn robust occlusion reasoning across diverse domains. Here we show qualitative comparisons between Samuel and AIS-Former. Samuel yields masks with better boundary precision and more accurate occlusion estimation, even under complex object overlaps or cluttered scenes. These results demonstrate that Samuel can effectively infer full object extents from partial visibility, just like human perception. Samuel integrates seamlessly with different front-end detectors and improves performance by a large margin in standard settings. As shown in this table, Pairing Samuel with detectors such as RTM-det, ConNext version 2, and VIT-det leads to significant performance gains on CocoA-COS, D2SA, and MOVA datasets. To evaluate generalization, we test Samuel in a zero-shot setting by excluding CocoA-COS and D2SA from the training set, respectively. Even under this challenging setting, Samuel consistently outperforms strong baselines, demonstrating its robustness to unseen occlusion scenarios. In summary, Samuel is a flexible and effective model segmentation framework that adapts foundation segmentation models to reason beyond visible content. Thank you for your listening.